Yes, welcome back guys to India's largest learning platform, that is BYJU'S Exam Prep. And guys, today we have a session in BARC and HAL series for the subject machine design. So my dear, you already know that we have completed almost all the subjects. Now we are left with one more subject after this, that is industrial engineering majorly. So guys, please tell me, am I properly audible and visible to all of you or not? Then we are starting this session, and this is a very important session for BARC and HAL series. Okay, and you know that actually machine design weightage is not very high, but whatever the questions are coming, they are easy to make. So definitely the weightage wise may be lesser, but the number of marks what they would be asking, you can easily score. Yes, Captain Raj, hi dear. So we are starting the session now guys. So guys, this is some detail about me. So you know, today's subject is machine design, that is one of my expertise. And guys, you know, the more important topics if we are talking about in this subject are bearings, joints, okay, fatigue loading majorly. So we are having questions from all the topics, even from clutches, even from bearings as well. And you know, BYJU'S Exam Prep is a complete solution for GATE and ESC preparation. Not only for that, we are here for all other exams related to that, like BARC, HAL, HPCL, all these kind of exams. So we are having series for all these types of exams. And now we have two channels for different audience. Like for English audience, this channel is there. For Hindi audience, we have GATE Hindi YouTube channel also. Okay. So let us move further guys. So there is a plan for GATE 2023 student. This is mastering concept. And in this plan, this is a 1 year complete free study plan. And my dear, you can see for mechanical, the time is 8 p.m. For civil, the time is 8 p.m. Computer science, 8 p.m. EEC, 10:30 p.m. Okay. So guys, you can join this session live. Okay. Sir, I want to learn EM from you. Dear, actually last year I have taken some topics of EM on the app, some topics of the EM on YouTube. Okay, so I will share the links of those some topics. Okay, so let us move further guys. And otherwise this year when I would be starting, then you can watch those lectures. So this is the very first question guys. So this is the very first question. If K is 3 for ball bearing and 3.33 for roller bearing, which one of the following correctly states the load life relationship for rolling contact bearing? So dear, these are your options. Please tell me the right option. Yes, and quickly like and share the session so that other students also reach here soon. I want more and more number, that will help you also to see the competition, to see the level where you stands. Yes, what would be the right answer for this? This question you can expect in both HAL as well as BARC, because the level of question in both these exams for machine design is not very high. Okay, Rohan is saying A. Okay, Captain Raj is also saying A. Kalpesh is saying C. Interesting. So dear, I would like to say that you know when we are going to see P L to the power 1 by K is equals to constant. This is the relation actually. So if you see P into L to the power 1 by K, so obviously P and L are in inverse relationship. So when you would be writing P, it would be C L 1 by K. Okay. So my dear, when you are looking at the inverse relationship, so obviously if L1 is in the numerator, obviously P should be in the denominator. So P1 should be in denominator. So if this is L1, this should be P1, this should be P2, and the power would be K. So just inverse to this is option number C. You can see L2 by L1 would be this. So dear, this option is matching L2 P2, L1 P1. C is the correct one. Very good, Kalpesh. Okay. Very good, Loga Vignesh. Rohan, actually it depends subject to subject, like production is high weightage subject. Okay, so I have seen the subject where weightage are less, their number of students are less. Students are already imagining that subject we are going to leave. Okay, so that is the major issue. So let us go to the second question. So dear, this is a question which is once again good for both HAL and BARC. You can have this question for both. Which of the following approximate relationship between the endurance limit and ultimate tensile strength of the material based on 50% reliability is not correctly matched? If you see, for steel, endurance is 0.5 times ultimate. Cast iron, 0.4 times ultimate. Wrought iron, 0.3 times ultimate. Cast aluminium alloys, 0.3 times ultimate. Yes. Okay, Kalpesh have answered for this question as C. Very good. What about others? Rohan, Loga Vignesh, Captain Raj. Yes, yes, yes. Quickly answer it, guys. Okay, Rohan is also saying C. Loga Vignesh, Captain Raj, what is your stand on this question? I want answer from everybody. Okay, Captain Raj is saying B. Okay, so dear, now I am going to tell you the answer. Actually, they were asking which of the following is wrong. So dear, C option. It is not correct actually. Why? Because endurance strength for wrought iron is 0.4 times ultimate. So that is why this statement is wrong and this option is correct. Okay, because they are asking the wrong statement. So for wrought iron, actually it is 0.4 times. So that is why the answer would be C. So I feel you got, because for cast aluminium alloys, obviously you would be having some more values of ultimate. Okay, so that's why it becomes 0.3 times. So it is correct only, Loga Vignesh. So answer for this is C. Let us move to the next question. Dear, this is interesting one. This is also good for both BARC, HAL, and even I will say this you can have in GATE 23 paper for 1 mark also. This can come for 1 mark in GATE also. So please tell me which one is going to be the correct answer for this. Yes. And please look at the statement properly. Then only answer. Okay, Kalpesh is saying B, Loga Vignesh is saying B, Aspirant is saying B, Rohan is saying B. Okay, very good. बहुत बढ़िया. Captain Raj is saying D. Okay. So dear, just look at it. They are saying a riveted joint with 4 rivet, number 1 to 4. This is eccentric loading of type 1. This is eccentric loading of type 1. Eccentric loading of type 1. Subjected to this, the least and the most stressed rivet. You know that the rivet which is near to the load is heavily stressed, and the rivet which is far from the load is least stressed. So 4 is the least stressed, 2 is the highest stressed. So my dear, the answer is 4 and 2. Actually, students generally do the mistake and they tick A also, because A is having 2 and 4. So this is just inverse. So B is correct one, A is not. Okay, so I feel now you got the rivet which is near to the load is the highly stressed. The rivet which is away from the load, that is the least stressed. So this is the theory behind this. Question number 4 is from the efficiency of riveted joint. This also I will say is of both BARC and HAL type. Don't worry, some questions we are having typical one also, but starting from the normal questions, because both exams ask some questions of this type. HAL is asking majority question of this type. BARC is asking at least 25-30% question of this type. Yes. Loga Vignesh is saying B. Kalpesh is saying B. Rohan is saying B. Very good, guys. Very good. So you need to find out the efficiency of riveted joint. It is coming out to be the ratio of diameter of rivet hole to the pitch of rivet. So 1 minus D by P. It is 1 minus 0.25. The answer would be 0.75. B is the right answer for this. Okay guys, B is the answer for this. Dear, actually when we are going to have the efficiency is defined as the minimum of PT, PS, PCR divided by P unriveted. So my dear, when you are going to do PT by P unriveted, this is tearing efficiency. When you are going to do PS by P unriveted, it is shearing efficiency. And PCR by P unriveted is nothing but crushing efficiency. So these are the three efficiencies. This is tearing, shearing and crushing. Tearing, shearing, crushing. Like this. Okay guys. Yes, moving to the next question. This is from clutch. This question is from clutch. Yes, a plate clutch of one pair of contacting surfaces, inner and outer dia of the frictional disc. DI is 100 mm. DO is 200 mm. And coefficient of friction is 0.2. 0.2. Permissible intensity of pressure, that is P maximum, what it can go up to 1 Newton per mm square. Assuming uniform wear theory, you need to apply and you need to find out the force. You know that when we have derived dF was integration P del A Ri to R naught. You know that P into 2 pi R dr. So I am giving you the hint along with. Okay, this will give you F force. You need to apply uniform wear theory. You can take P into R outside. So apply UWT. F would be P into R into 2 pi dr Ri to R naught. So F would be 2 pi. You know P into R is constant. So P maximum would be with Ri and P minimum would be with R naught. So here we would be writing P maximum because it is known to us, Ri. 2 pi into R naught minus Ri. Solve it and get the answer. I have make everything easy for you. You just need to put the value now. Loga Vignesh is saying the answer to be B. Yes. What about others? Rohan, Captain Raj, Kalpesh. What would be the answer? This is majorly good for BARC, not for HAL. Rohan is saying B. Yes. Very good. What about others? So the answer would be B. Surely B. So the answer is 15707.96 Newton. Yes guys, very good. Wonderful guys, wonderful. B would be the right answer for this. Okay. Next question is 6. A single clutch operating under dry sliding condition transmit 150 Newton meter. So torque is given as 150 Newton meter. The average coefficient of friction is 0.3. 0.3. Maximum operating pressure is 0.5 MPa. The ratio between outside radius and inside radius, RO by RI, is 1.73. Under uniform wear condition, uniform wear, find the outside radius, if the outside radius of the clutch is to be minimum, okay, for R naught minimum, what is RI? Because pressure is maximum, so you need to find out RI. Very good, guys. Solve this question. This is question number 6. Okay. So once again, you need to repeat what we have seen previously. Okay. So you know, I feel the load value is 2 pi P max RI, R naught minus RI. This is the load value. Okay, this is the load value. And you know, torque is 1 by 2 mu W R naught plus RI. This is the frictional torque. Yes, guys. Yes, guys. Solve it, solve it, solve it. You need to find out RI. Here, when you would be putting all the things, you know, R naught is in the form of 1.73 RI. Then W would be coming out to be 2.293 RI ka square. This is what you are getting in terms of RI. Small RI, capital RI, whatever you want to write, you can write. Putting this value, you would be finding out RI. Okay, Rohan is saying 54.3. Okay. What about others? Captain Raj, Loga Vignesh, Kalpesh. Yes, yes, yes. Solve it, guys. Yes, guys. So I would like to say the answer calculated by Rohan is correct. 54.3 is correct. Actually, you would be getting 54.25. So formulas are in front of you. You just need to put the values and get the answer. So dear, actually machine design questions are lengthy. Okay. So that is the nature of machine design questions. Move to the question number 7. This is from gears. This is an easy question. You need to find out the center distance between the two gears. So there are two gears, one gear, second gear. So you know, this is R1, this is R2. So this is the center distance. It is R1 plus R2. So it would be M1 T1 by 2, M2 T2 by 2. You know module would be same. I have written the formula, you just need to find out the answer. Dear, actually I would like to tell you, Rohan, cutoff for BARC is not a constant number. It keeps on changing and depend on how the paper was. If you see the previous papers, many times cutoffs have been changed by 30, 30, 40, 40 marks. 30, 40 marks here and there it have been in the previous years. So there is no fixed cutoff, but yes, for sure, it will depend on the papers, that it is difficulties level. So if the paper would be more lengthy, yes, it is generally of lengthy lengthy type ka paper hota hai. So in that way, it is going to be on the lower side. But if the paper is coming easier, it may go on to the higher side. So there is no fixed number. It keeps on changing every year. Loga Vignesh is saying D. Rohan D, Captain Raj D, and yes, you guys are correct. This type of question you can have in HL also. This type of calculation which you can do very easily. You can have this question in both types of exams. Okay. Fine. Okay, Rohan. Then there are chances. I am thinking that around 150 if you reach to would be very feasible for your selection. This is the question from brakes. And this type of question we can expect in BARC. Because here calculations are involved much. Okay. So this is from shoe brake actually. This question is from shoe brake. You know, you would be making some free body diagrams. So free body diagram of drum would be like this. Here it is N. It is already given that it is rotating in anti-clockwise. This is the direction of rotation. So if it is rotating anti-clockwise, this is going to be the mu n. And my dear, if you see the shoe, then on the shoe, this would be the N. And if friction is here, here friction would be here, mu n. So guys, this is point O and you need to put summation moment O is 0. Frictional torque is mu n R. So when you are going to do the summation moment O to be 0, this F is creating anti-clockwise. So minus F into 1000. So I am giving you the hint. Minus F into 1000. This N would be creating clockwise. Plus N into 300. Mu N would be clockwise. Plus mu n into 40. So dear, mu is given to you. You just need to put the value and you will get the value of n, because it is already mentioned that torque is there. So you know torque is 300 Newton meter would be mu n R. So you would be getting n from here. Putting n, you will get F from here. Solve it. I have given all the calculations required here along with the free body diagram. Solve it and get the answer, guys. Solve it and get the answer. Yes, Rohan. Okay, Rohan is saying A is the answer. Let me check it. Question number 8. What about others? Captain Raj, Loga Vignesh, and Kalpesh. Solve it and get the answer, guys. Yes, yes, yes. Okay, Loga Vignesh is saying B, Captain Raj is saying B, and yes, the answer is B. So the answer would be coming out to be 1248 Newton. B is the correct one. 1248 Newton. 1248 Newton. Very good. Now this is the question from welded joint. This is the question from welded joint. And in welded also, this is a special case. For that, you know, we have found out the answer as 2.83 T by pi r cube T. Is it correct? Yes. So what would be the answer for this? What would be the answer, guys? Yes, pi d cube T. Sorry, it was pi d cube T. Pi d cube T. Good. Loga Vignesh. Solve this question. This is from welded joint. So what you need to find out, actually, you need to find out the maximum torque. So this you need to find out. 100 mm dia shaft. D is 100 mm. Weld size 16 mm. If the allowable shear stress you need to find out torque. Okay, so you would be writing tau max is less than equals to tau allowable. So 2.83 T by pi d cube T less than equals to 50. Torque would be so Captain Raj is saying B. Loga Vignesh is saying B. Rohan is saying B. I am also saying B. Okay. So answer is 2.82 pi. Very good, guys. So B is the answer for this for sure. Let us move to the next question. Question number 10. This is also from the block break. This is also from the block break. So in this block break is shown in the figure below. The diameter of brake drum is 200 mm. Diameter of this is 200 mm. Mean coefficient of friction is 0.25. Force is 500 Newton. You need to find out the braking torque. So you know very well that braking torque is mu n r. So if this is the drum, this is rotating like this. So here would be mu n, here would be n. So here would be mu n, here would be n. Apply summation moment O to be 0. You know this force is creating clockwise. 500 into 500. This is creating anti-clockwise, minus n into 200. This is creating nothing because it is passing from the same point. You will get n, putting n you will get braking torque. Yes. Question number 10, guys, what is the answer? So dear, as you know, we have two sessions for machine design. One is today, one is day after tomorrow. So today we are going to have some questions we would be having day after tomorrow. I would try to add engineering mechanics question also, because all the topics I am covering today also for machine design. Yes, Loga Vignesh, Rohan, Captain Raj, Kalpesh. What is the answer for this one? What would be the answer for this? Okay, Captain Raj is saying A. What about others? Loga Vignesh, Rohan, Kalpesh. What is the answer, dear? Getting double of option A. Dear, I feel you are putting diameter. This is 200 mm is diameter. Radius would be 100. I feel you are doing this mistake. Just check it. It is not gate. If you would be having, okay, you are also getting Loga Vignesh the same thing. Yes. Yes, I feel the answer would be 31.25. Yes. Sorry dear, actually the answer would be 31.25. 31.25 is the answer. Yes. Actually, when you would be having this value force, you would be getting mu into n, as mu into n would be coming as 312. I feel 312 or something like that. 312.5. Yes, obviously you are correct. So answer would be 31.25. Yes. You are correct, guys. Sorry for this inconvenience caused. Question number 11 is once again from the gears. Spur gear has a module of 3 mm. Number of teeths are 16. Face width 36 mm. Pressure angle is 20 degree. Power is 3 kilowatts. N is 20 RPS. Form factor 0.3. Sigma B permissible 200 MPa. Find out the beam strength. MBY. Sigma B permissible. You need to find out this. Solve it, guys. Okay. You must see one thing, that velocity factor is also given. So don't forget about it. CV into F beam. Okay, Captain Raj is saying C, Loga Vignesh is saying A. One of you is definitely correct. Okay, so I feel Captain Raj is correct. So beam strength is 4320 Newton. 4320 Newton. 4320 Newton. Is it clear? 4320 Newton. Next question. Dear, it is from ball bearing. A ball bearing is subjected to a radial load of 2500 Newton. Radial load of 2500 Newton. And an axial force of 1000 Newtons. The catalogue gives the following thing: radial load factor, axial load factor, load rating, static, dynamic load carrying capacity. Find out the life. Wonderful question, guys. B is the width, dear. B is the face width. In the previous question, B is the face width. If you see B is the face width. If you have this as gear teeth, so this is B actually. Okay. Is it clear, guys? Yes. So I am giving you hint for this also. PE you can find out as X V FR plus Y FA into S. There is no service factor given, take it 1. Okay. V is not given, take it 1. Put the values of others. You will get PE value. Okay. So PE L90 K is constant. K or 1 by K? Solve it. Okay, many of you have given the answer. Rohan is saying C. Loga Vignesh is also saying C. Okay, what about others? First of all, find out equivalent radial load, and we will be getting equivalent radial load as 2500 Newton, guys. So you just need to put L90 as C by PE to the power cube. 27 would be the answer. Is it clear, guys? Very good. So this is the answer for this. Question number 13 is once again from the, this is also from the ball bearing. A ball bearing subjected to a radial load of 3000 Newton is expected to have a life of 40 million revolution. So my dear, 3000 Newton, life is 40 million revolution. And this is with a reliability of 95%. Similarly, we have desired reliability of 50% and life is to be asked. So what is life for 50% reliability? You know, we can do L50 by L95, ln 1 by 0.5, ln 1 by 0.95, 1 by 1.17. So you can find out the desired one. You can also first of all find out L90, then you can go 5 times of that. You know L50 is 5 times of L90. You can also find out L90 first, then multiply it with 5. Totally your choice. Yes, guys. Very good. Captain Raj is saying D. Loga Vignesh is saying D. Answer is D. Rohan, you got it or not? So the answer for L50, 370 millionth revolution. I feel there is a mismatch in number. 15th by chance came before. Okay, so don't mind it. So this is from the journal bearing. This is from the journal bearing, and guys, in this the shaft diameter is given to us, length is given to us, speed is given to us, viscosity is given, clearance is given, and we need to find out the radius of friction circle. So dear, I would like to tell you that radius of friction circle is nothing but mu times of r, because you know it was r tan theta, so mu times of r it is. So you need to find out mu times of r. Solve it, guys, and get the answer. So the data is L is equals to D is equals to 40 mm. Speed is 20 radians per second. Viscosity is 20 into 10 power minus 3 Pascal second. Clearance is radial load is 2 kilonewton. Find out mu times of r. Yes, guys. Yes, yes, yes. Okay, Captain Raj is getting D. Yes, Rohan. First of all, you need to find out the pressure W by LD. This will give you pressure to be 1.25 MPa. Then you know coefficient of friction is Zn by P D by C 2 pi square or 2.006 pi square. This will give you mu, and mu times r is our answer. So it would be coming out to be, dear Rohan, you are wrong. Captain Raj is correct. Answer would be 0.06. Okay, 0.06 mm would be the answer. So guys, we have done a number of questions, 15 questions around we have done. In the next section, which is day after tomorrow, we have around 20 more questions, where some questions I have considered from engineering mechanics also. So around 10 questions would be from machine design and some would be from engineering mechanics. So be ready for that. So day after tomorrow, once again we are going to meet. So guys, quickly like and share the session so that this video can reach to the maximum people, because they are wonderful question. You can have the similar or same question in the exams also. Be ready for that. So guys, and I would be sharing the PDF of this on the Telegram channel. So goodbye guys for this session. Thanks for joining and thanks for your love and support. Is it fine guys for today? Great.